in Java execution process, this JVM plays a very important role. Okay, now how JVM will work and what are the components involved in Java application execution. So each and everything now I am going to explain. Okay, so let's get started. Yeah, so this is my, assume this is my Java file. Okay, this is my Java file. Now I want to execute this Java file. Now how to execute this Java file means, so we need to, before executing Java file, you must compile your Java file. So why we need to compile the Java file means, so for checking the errors. Okay, for checking the errors. So compilation is nothing but it will check this compile. What it does means, it will verify all syntactical errors in your Java. Okay, so after successful compilation, after rectifying all your errors and after successful compilation, it will generate one .class file. Okay, it will generate not one .class file, so it will generate .class file. Okay, so how many classes in your Java file, so that many .class file it will generate. Okay, suppose take an example, so I have a so I have a program. Okay, so it's a demo program. See here, so this is my class demo, and in this file I have total, so 1 2 3 4 plus this class, so 5, total 5 classes I have. Okay, so now I'm compiling my Java program. So just to type cmd here, so automatically it will open. Now type dir, it displays the dir command, means it displays the list of directories, means list of folders and the list of directories it will display. See here, so as of now in my directory I have only one file. Okay, so the file name is what, demo.java. Okay, demo.java. Now I want to run this Java file. So how to run this Java file means, first we need to compile your Java file. So first compile. So Java, how to compile, how to call the compiler means, we need to call a command java c for compiling. Okay, java c space your file name. What is my file name? Demo.java. Okay, demo.java. Now this process is called compilation. Okay, now it is compiling. Yes, done. Okay, so now we need to verify whether it is a compiled or not. So after compilation, so what will happen? After compilation, it will generate .class files. Now we'll verify how many .class file it generates. Yeah, see here, earlier I have only one Java file. Now this time it is what? So it generates 5 .class file. See here, it is a class file, means it's a .class file. Okay, now A, B, C, D and demo. Okay, so demo also one of the class. Now so total 5 classes it generates. See, demo 1, 2, 3, 4 and 5. So total 5 .class files it will generate. Okay, total 5 .class files it will generate. So now I want to run this program. Now how to run this program means, we need to call java space demo. So now it will display hello world. Okay, it will display hello world. Why means, in my program I am displaying one message, that is a hello world. Okay, so these classes I am not calling anywhere, so that's why it is not showing anything here. So I am just printing one message, that is what, hello world message. Okay, now this is what execution process of your Java. Okay, this is what execution process of your Java. Now we'll see how this process is done. Okay, first it is my Java file, demo is my Java file. So we are calling a command that is what, javac space filename.java. That is a compilation. After compilation, it generates .class files. After compilation, it generates .class files. Okay. Now after generating .class file, again you are calling one command that is what, java space file name. Java space file name. That is what, you are running your Java program. You are running your Java program. Now that is what execution of your Java program. Okay. Now we'll see what are the steps involved in execution of your Java program. We'll see. JVM having mainly three parts. Okay, so first part is a class loader subsystem. Okay, first part is a class loader subsystem, and second one is runtime data areas. Next, the third one is execution engine. Okay, so first one is what, class loader subsystem, and second one runtime data areas, and third one execution engine. Okay, now we'll see one by one. Class loader subsystem. So class loader subsystem, so what it does means, so what are the responsibilities of class loader subsystem? Means, okay, Java having one distinctive feature. So what is that means? Java is a dynamic. Okay, how can we say Java is a dynamic? Means, so while executing Java program, it will not load all .class files into the memory. It will not load all .class files into the memory. It will load only currently executing class respective .class file only. Okay, it will not load entire program into the memory. It will load only currently executing class that respective .class file only. Okay, but if you take C program, in C program, suppose I have a program like hash include stdio.h, hash include stdio.h. After that, here I'm taking main. So this is my sample program. So assume, so this is my program, and in my program I have some content here. So up to here this is my program. Now before executing this program, first it will execute this header files. It will load all header files data into the memory first. After that it will load this program into the memory. Okay, but this is not happen in Java. In Java it will execute only currently executing class respective .class file only. Okay, so who will take care of this? Means this class loader subsystem will take care of this. Okay, in this class loader subsystem, again it having three phases. The first phase is loading phase. What? Loading phase. So in loading phase, again this class loader subsystem having three phases. First phase is loading phase. Okay, first phase is loading phase. Next phase is linking phase, and last one is initialization. So these three are the what phases in class loader subsystem. Okay, again the first one, loading. Okay, in loading again we have three parts: bootstrap class loader, extension class loader, next application class loader. Okay, so while executing your program, sometimes you may be load the class from different folders. Okay, sometimes you want to load files from some rt.jar folder. Okay, in that, so bootstrap will load that particular class. Okay, and sometimes you may want to load your class from jre/lib folder. Okay, in that case, so extension class loader will execute. Okay, and sometimes you may want to load your class from environmental variables. Okay, in that case this application class loader will be execute. Okay, so this is what loading phase. Okay, in loading phase it will load only currently interacting or currently executing class respective .class file it will load. Okay, after performing loading operation, next it will perform what linking operation. Okay, now why we need to perform linking operation? Okay, why we need to perform the linking operation? And again, so Java having one more distinct feature, that is a secure. Okay, one more feature, that is a secure. So how can we say Java is secure? Okay, means the chances of spreading viruses by using Java or Java applications is very less compared to other applications. How means? So each and every phase it will verify, for each and every class it will verify whether that compilation has been done properly or not, that is a valid compiler or not, and that bytecode is properly organized or not. It will verify by verify. Okay, it will verify by verify phase. After performing verification, after done with verification, so it will prepare. Okay, it will prepare. So prepare means, suppose in your program you may have static members. Okay, so as of now you may not aware of what all variable types and how it will work, but as of now just listen. So after that you will come to know so what is the static variables and everything. So in your program you may have what static variable. Okay, in static variable that initialization will be done here. Okay, if you are not initializing your static variables, that will be initialized with the default values in prepared section. Okay, after that, after performing these two operations, if any difficulties or if any problems rise, so that will be resolved by resolve phase. Okay, so this is what linking. This total is what linking phase. Okay, after done with linking, so it will send to initialization section. So initialization section is a last phase of class loader subsystem. Initialization phase is a last phase of class loader subsystem. Now in initialization, so what it does means, what will happen means, so in linking phase, suppose you may have some static members or static variables. That static variables are initialized with the default values. Okay, now in initialization it will be initialized with actual values. It will be initialized with actual values. So this whole process will be done in class loader subsystem. Okay, this whole thing is done within class loader subsystem. Next, so after class loader subsystem, so we have one more type, that is what runtime data areas. Okay, so runtime data areas. Okay, so what is a runtime data area? Okay, means while executing your Java program, so your Java program may have some data. Okay, your Java program may have some data like some variables or some objects. Okay, this data must be stored in some area. Okay, that storage areas or the storage options are nothing but runtime data areas. Okay, so this is what a memory section. Okay, so this memory section again divided into five different types. The first type is a method area. Second is a heap area, and third one is a stack area. Next, fourth one is a PC register, and the fifth one is a native method stack. Okay, so these five are the different memory sections. Okay, these five are the different memory sections. Okay, so now coming to first area. So what is the first area? So method area. Okay, so method area. So what method area means, what method area will be stored. So it will store all class level data, it will be stored here, including static variables. And so there is only one method area per JVM, and it is a shared resource. Okay, so this method area will store only class level information. Okay, it will store only class level information, and it is a shared resources. So that's why, and it is only one method area per JVM. Okay, that is the reason it is not thread safe. Okay, this method area is not thread safe. Why? Means it is a shared resource. Okay, and this method area will be stored all class level information. Okay, and static variables it will store. So this is what method area. Next part is what? Heap area. Okay, so being a Java developer, so you must aware of these memory areas. Okay, then only you can write efficient Java program. Okay, so heap area will be stored, means it store object kind of data. Okay, it will store all object means what? You are creating some space in memory. Okay, that memory is nothing but heap. Okay, all objects will be stored in heap area only. Okay, and all instance variables are stored in heap area. Okay, next, heap area also what, one per one JVM. Okay, one per JVM, and it is also shared resource, and it is also not thread safe. Okay, it is also not thread safe. Next, third one is a stack area. So this stack area consists what? Different threads. Okay, suppose in your program, so you may have 3 threads. So for every thread it will create a separate stack. Okay, so this is called one stack, and this is called another stack, and this is called another stack. Okay, and so each stack consists some stack entries. Consists some stack entries. Okay, so for what kind of data will be stored in stack area means, so it will store all method call information, and it will store all local variables. Okay, all local variables. And for each and every method call, it will maintain one separate stack entry. For each and every method call, it maintain a separate stack entry. And this stack entry also again divided into 3 types. Okay, so first one is what? Local variable array. Okay, first one is what? Local variable array. So this will maintain what, how many local variables involved in method call. Okay, and next one is operand stack. Operand stack means, so suppose in your program, in your method, you may have some arithmetic expression. Okay, in that expression, so how many operands are involved, that information will be maintained by operand stack. Means all plus, minus, multiplication, division, all that operand information will be stored in operand stack. Okay, next is frame data exception. Okay, frame data exception. Sorry. Next, it having what? Frame data. Okay, so it will store what, all symbols, and if any block, in method, if any exception is raised, that exception information will be stored in frame data. Okay, it will store frame data. Okay, the first is what? LVA means local variable array. So it will maintain how many local variables are involved in method call. Okay, that information will be stored in LVA. And next is what? This one, operand stack. Means operand stack means what? It will maintain all operands information. Means suppose in your method you may have some arithmetic expressions. So in that arithmetic expressions, so how many operands are used, that information will be maintained by operand stack. So next is what? Frame data. So that frame data will maintain what exception information, means in your method call, so some any exception may be raised, that exception information will be stored in what? Frame data. Okay, so this is what? Stack area section. This is what? Stack area section. So next one is what? PC counters. So PC counters, so PC registers. So PC registers means, so while executing your Java program, each and every instruction will be maintained in registers. Okay, PC means a program counter register. Okay, program counter register means after executing first instruction and again it will update to next instruction. Okay, likewise it maintain on stack. Okay, so this is what? PC registers. So next is what? Native method stack. So in native method stack, so it maintains all native method information. For every thread, a separate native method stack will be created. Okay, for every thread, separate native method stack will be created. Okay, so these are the runtime data area sections. Okay, so total we have 5 different sections we have. The first section is a method area. Method area will store all class level information and stack variable information. Next is a heap area, and the heap area will be stored objects information. Next instance variable information, and these two are only one for JVM, and these two are these two are shareable, so that's why it is not thread safe. Okay, next is what? Stack area. This stack area consists, for each and every method call or for each and every thread, it will create a separate stack, and in every stack it will maintain different information, like so it will maintain what? Local variable information, it will maintain operand information, and it will maintain exceptions information, and it will maintain all method call information. So this, it will create for each and every thread, it will create a separate stack for each and every thread. So that's why this stack area called thread safe. Okay, remember this stack area called thread safe. Next is a PC counter. So PC counter means this is a program register counter, program counter registers. This will maintain what? All instructions. So all program is executing instruction by instruction. So after executing one instruction, it will update to the next instruction. So who will take care of means the program counter registers. Okay, so next is a native method. Okay, native method stack. So this will be stored all native method information, and it will create for thread a separate stack will be created. Okay, so this is about runtime data areas. Okay, this is about runtime data areas. Next, third one is execution engine. Okay, next third one is execution engine. Okay, this execution engine also called heart of JVM. Okay, this execution engine also called heart of JVM. Okay, why means all the execution process will be done here only. Okay, so this execution engine having several components. The first component is an interpreter. The first component is called interpreter. So as I said, so Java is a interpreted. Okay, Java is a interpreted. So how can we say Java is a interpreted? Means this interpreter will interpret the code by line. Okay, so but this interpretation, while interpretation, so it having some disadvantage. So what is the disadvantage means? Suppose take an example. This is my sample code. So in my code I have a wish method. I have declared a wish method. So this is a wish method. Okay, so in this wish method, so in this program, so this wish method called 4 times. So this one is a method calling, and this one is a method calling, this one is a method calling, and this one is a method calling. Okay, so while interpretation, so after performing interpretation, so first time it will interpret this method. after that, so whenever method call happen, again interpretation is required. Okay, and here method call happen, again interpretation required, and here the method call is happen, again here interpretation required. So how many times you are calling this method, that many times interpretation is required. So that is the main problem with interpretation. Okay, instead of interpreting once, it is interpreting and each and every method call. So that is the problem with interpretation. So to avoid this problem, they have introduced one more component called JIT component. One more component is called JIT. JIT is nothing but just in time compiler. JIT is nothing but what? So JIT is nothing but just in time. Just in time compiler. So this compiler, how this compiler will work means, this compiler optimize the code. This compiler optimize the code, and it will remove all unwanted spaces and all unused methods and all unused lines, and what will happen means, it will maintain a separate record for method calls. It will maintain a separate record for method call. Means, so here it maintain one component. It maintain one component that is called profiler component. It maintain one component called profiler component. This profiler maintains the method information. Means how many times a method is repeatedly called. Okay, that information it will maintain. So suppose if a method calls multiple times, so this method is now it is calling 4 times. So now this method is now treated as a hotspot. Okay, now this method is treated as what? Hotspot. So this method is called hotspot. Okay, now who will decide this? Who will decide this means this profiler component will decide the hotspot. Okay, so likewise this JIT compiler will work, and after identifying the what hotspot, it will generate the code for mesh. It will generate the code like machine code or native code. It will generate for that hotspots. Okay, so that next time if any method call will happen, so directly it will not interpret that method, and it will execute that hotspot machine code. Okay, so likewise this JIT compiler will work. Okay, so this is about JIT compiler. Okay, so next component is garbage collector. So next component is garbage collection. So this garbage collection. So garbage collection means what? As name suggests, it collects all garbage in program. Okay, it collects all garbage in program. Means it collects all unused objects in your program, and it collects all unreferenced objects from your program. Okay, and it will clear the memory so that your program will be healthy and strong. Okay, so that's why one more distinct feature is there, that is what Java is a robust. How can we say Java is a robust? Means because of this garbage collection. This is one of the reason why Java is a robust, means because of this garbage collection. Okay, after this execution engine, so we have one more phase is there, that is what a native method library. Means while executing your program, so in your program you may need some libraries. Okay, some native libraries. In that case, you need to access native method library by using Java native interface. By using Java native interface, you can access this native method libraries. And while saving the data, also sometimes you need to access what some libraries. In that case, you can access by using JNA. JNA is nothing but Java native interface. So this is about JVM architecture. Okay, so I hope you understand. So if you have any queries, you can post in comments.